So this is the first problem of the contest. Make it easy. The problem says that we have been given a horizontal strip of n cells. Each cell is either white or black, and we can choose a contiguous segment of cells once and paint them all white. And after this, all the black cells in the segment will become white, and the white ones will remain white. And we have to tell what is the minimum length of the segments we need to choose, or of the segment which we have to paint in order to make all the n cells white. So the problem is like this. We have been given, I think we have been given a string. Yeah, we have been given a string of n length where every character is either B or W, representing either black cell or white cell. And what we have to do is we can choose a subsegment, or you can say it as a substring, and change all the blacks in that substring to white. So if we choose a substring like this, it will become like this, right? And we have to tell what is the minimum length required for the substring which we can choose to make all the elements in the substring equal to white. So here in this case, we could just choose this substring. Let me mark it here. We could just choose this substring and make all the elements white, all the cells white, right? So guys, is the problem clear? Is the problem clear? We want to choose a substring with minimum length. So here you just had to make some simple observations. Like if you choose any substring like this one or whatever, in which any black cell is be in any black cell is missing, in that case you would not be able to convert all the black cells to white cells, right? So at the very least, your substring must consist of all the black cells, which means that the length, like the segment you choose, must start from any place before or equal to the first occurrence of black cells, and at least till the last occurrence of black cells, right? This is one of the observations you should have made, that at least this much should be the length of the substring. So we know that any substring which consists this many or more elements like this one or this one will make all the cells equal to white. And since we want to find out the minimum length, it is obvious that taking any extra element in this segment which is not black doesn't make any sense, because it will only increase the cost or increase the length without having any benefit, right? So I think that it is pretty intuitive from here that you will just choose a subsegment or choose a segment starting from the first occurrence of black cells till the last occurrence of black cells, right? So if I say that here last, this is a variable which is representing the index of the last occurrence of black cell, and first represents the first occurrence of the black cells, then last minus first plus one would be the length. This will be the length of the segment with which you will have to choose. This is the minimum length. Why are we having a plus one here? You can just do a dry run to get understand this thing. Let us say the indices here are 0, 1, 2, 3. So the last occurrence is 3, first occurrence is 0. And you know that if you just do 3 minus 0, it will not give us the thing 4. You would have already studied about this in school, that to get the number of elements from some number to some number, we say higher minus lower plus 1, right? So I hope that the problem is clear and we can move on to the code. Guys, please confirm in the chat. What if there is only one white tile? Okay, there is one more thing. Somebody said that what if there is only one white cell, or probably want to ask that what if there is no black cell? In that case, the answer will be 0, right? You will never have any first occurrence, you will never have any last occurrence. So with whatever value you define them at the beginning, you will just have them equal, and Last minus first plus one will actually give you some different thing there actually. Okay. You will have to manually handle that case, I guess. In that case, probably I missed this test case. It's so bad for me. Okay, like just simple thing. If you say that there is no black cell, in that case, you have to print zero. Now you can manually handle that case or just mess up like me. So let me show you my code, which is, um, did they actually mention that there will be at least one? Yeah, there is at least one black cell in the problem it has been given. I just missed this thing during the contest. Okay, so in the problem, there is one more thing, that there is at least one black cell in the given thing. And probably they gave this so that the people who just forget about this edge case doesn't get the problem wrong. So here in my code, I'm just going on for every test case. This is taking P as the input. For every test case, I'm taking n and string as the input. After that, I'm just running up a for loop to find out the first and the last occurrence. And after finding out the first and the last occurrence of the element, sorry, of the string, I'm just saying last minus first plus one. That will be my answer. I hope that this is clear, right? So let's see the next problem. The second problem is following the string. In this problem, we are being told that Polycarp lost the string s of length n consisting of n lowercase Latin characters, but he still has its traces. We will see what is the trace. So a trace of the string s is an array a of n integers where ith element of the array, or you can say ai, is the number of indices j, which is smaller than I, where si is equal to sj. For example, if you have been given a string like this one, whatever the string is, abrac. So for every index, like just look at it. For the index 0, there is no character on the left of this a, which is equal to a. So at this position, you will have a 0. Then for b, there is no character on the left side of b, which is equal to b. So again, there is a 0. Similarly for r. Now for this a on the fourth index, there is only one character available on the left side of this a, which is equal to itself. That is this a. So we have a 1 here. And similarly, you can just check out for all of the indices. And I hope that the problem is actually pretty straightforward. So you would be able to understand this thing. We have been given the trace of the string. So we have been given this array, and we have to give any string s, like not this one. You can just give any string for which you will have the same trace, like from which you will get the same trace, and this string should consist of only lowercase Latin characters consisting from a to z. So I hope that the problem statement is clear. It is already quite straightforward, that you will have a string. Maybe let me take an example: a b c a a b c. For this kind of a string, let me show you how to find out the trace so that you will have some better clarity. For this a, there is no element on the left side of it which is equal to a, so the trace would be 0 for this element. For the second element b, again there is no element equal to it on the left, so again there will be a 0. Similarly for c, for this a, there is one element on the left which is equal to it. So like for this a, there is just one element equal to it, so we will have a 1 here. Then for the next a, there are two elements, this one and this one, which is equal to a. So we will have 2 here. For this b, there is one, and for c also, there is just one element on the left. So we will have 1, 1 there, right? This will be the trace. And Ananya actually wrote this thing in the chat as well. Great. So I hope that you know how to find the trace of a string now. Now in the problem, it says that we have been given this trace. We don't know about the string. We have to find out any string. The string can be anything. The thing is that, like, the only conditions on it is it should have only characters from A to Z, and whatever string you find out should have the same trace. That's it.
Can you explain me this trace, like how this trace is written for ABC, A, B, C?
Okay. So for this A, you know that there is no element on the left equal to it, so it is having a 0 here. For this B, there is no element on the left of B which is equal to B, so we have a 0 at the same index in the trace. Now C, which comes on the third index in the string, there is no element on the left of it which is equal to C. So in the third element of the trace array, like on the third element of the array, we are having a 0 again. Now for the fourth index of the string, there is one element, that is this A, which is equal to this guy. So we will have 1 here at the fourth index of the array. Similarly, for the fifth index, there are two elements on the left of this guy. If you see that here I is equal to 5, and there are two values of j equal to 1 and j equal to 4, where si is equal to sj, right? So that is why we are having a 2 here. And similarly for b and like these two elements, for the sixth index, there is only one element on the left, that is on index 2, which is equal to this guy. So we will have a 1 here. And similarly for the C, there is only one element on the left of this guy at the seventh index, which is equal to, sorry, at the third index, which is equal to the element on the seventh index. So we will have one at the seventh index of the array. Is it clear now?
Yes, yes.
Okay, great. So I hope that the problem is now clear. What we are being given is this trace, and what we have to find out is any string which has the same trace. Now, even if you had a string like A, C, B, A, C, B, even for a string like that, or even for a string like B, C here, the trace will turn out to be the same. You can just verify this thing. So um, any of that will pass, even a string like A, B, C, D, B, and maybe CA, something like that as well. Or even if you consider elements like PQ inside it, would also be great. Okay. So the problem is, like, I think it's quite straightforward. Like what you have to do here is, initially you are having elements A, B, C, D, and till Z, which are coming zero number of times. None of them is coming even one of like one of the times. You know, when you have covered no elements of the string. So for the first element of the string, we have been told that there should be a character at the first index, which has not come up so far, right? So we see that all of these elements satisfy this. So you can just place any character at the first position. Let us say somebody said, "Okay, I will place D at the first position." So after that, when you talk about the second position, for the second position, you will have A, B, C, and all characters till Z coming up zero number of times, except D, which is coming up one number of time so far in the string, right? Do you guys, did you guys get this thing? Are you able to understand this? That for any element on this index, if you see on the left, there is only one D, one element D, which has come up one number of time, and everyone has come up only zero number of times. Now, for the second element as well, it requires you to place up something which has not come so far. So let me say ki I will just say ki I will place C at this position. So C and D would have come up one number of time, and all the characters A, B, E, F, and so on till Z would have come up only zero number of times. Now for the third position as well, it requires you to place a character which has come up zero number of times. So again, from these characters, you can just pick up any one of them. It's up to you. Let's say you randomly pick up Z. So now C, D, and Z would have come up one number of times, and all the other characters have come up zero number of times. Now this time it requires you to place a character which has come up one number of time. So only these are the characters which have come up one number of times. So you can place any one of them at this place. Let us say you place Z here. So now C and D have a frequency of 1 each right now, and Z has a frequency of 2, right? After that, you have to place a character which has come up two number of times in the first four occurrences, and we have only Z. here, so we will have to place z here. We doesn't really have any choice right now. And you can do this for the rest of the string as well. Like after this, you have to place a character which has come one number of times. So you will say ki I will place d here. D, the frequency of d so far is 2, and c has a frequency of 1 now. And now again you have to place something which has come up only one number of times. You have only c here, so just place c here, and c and d will have a frequency of 2 now. And like you will have, we have got a string like this which has the same trace. You can verify this thing if you want, though we have just created the string from the trace itself, so it's okay even if you don't verify. Okay, so did you guys understood what we did?
Yeah, we did.
Yeah, there was no tricky part in the problem. Like if you see in the problem, there was absolutely no tricky part. They had been very straightforward here. From this trace, you have to form something for which obviously you can just do something like this. There can be some more ways you could have thought of, like using map or something, but that will just make the problem more complicated for beginners. Okay, so let's see the code here. What I did for this problem, like the code I did for this problem is, for every test case, I'm taking the number of elements as input and then the whole array as input. After that, I'm having a count array of size 26, where let's say if you talk about the first index of the count, it will store the frequency of frequency of b. And similarly, count of 4 will store the frequency of c and so on. Sorry, frequency of e and so on. Like probably you would have just guessed this thing. Since there are only 26 characters, I created an array of size 26, so that in the 0th index, I will store the frequency of A. In the first index, I will store the frequency of B, and so on till Z. है ना? In the 25th index, I will store the frequency of Z. Right? I'm just doing this thing. Probably you would have already done this. Probably most of you would have already seen this thing anywhere. Otherwise, you can just now try to code it. Okay. So what I'm doing here is just going on for every element in the uh, given array, and then for every element I'm just going on for the 26 English alphabets I have, and just checking if any one of them is having a frequency equal to AI, the character which I required, like the frequency which I required at this place. As soon as I find a character, I will just place that character at the end of the string answer and increment its frequency, and then break this loop, inner loop, so that I will go on to the next element. Okay, so does this make sense? Does this make sense?
This will this not TLE, because n is has a bound of 10 power of 5, and then t is 10 power of 4, so 10 power of 9, right?
See, they have mentioned that the sum of n over all the test cases does not exceed 2 into 10 raised to the power 5, right?
Okay.
So, see, they have mentioned that the sum of n over all the test cases will not exceed 2 into 10 raised to the power 5. So, like the sum right now you're saying that t can be as large as 10 raised to the power 4 and n can be as large as 10 raised to the power 5, 2 into 10 raised to the power 5. So you are thinking key, in the worst case you will have n into t number of test cases, right? That's
Yep,
what you are thinking.
yep.
But in the problem they have actually mentioned that the sum of all the test cases, like sum of n over all the test cases, will never exceed 2 into 10 raised to the power 5. So the case of having 2 into 10 raised to the power 5 number of, like length of that for all the test cases, will never happen. Instead, the let's say if you are having 10 raised to the power 5 value of n equal to 10 raised to the power 5 in the first test case, then in the uh, then in all the other remaining 10 raised to the power 4 minus 1 number of test cases, the sum of n would be just equal to 10 raised to the power 5, because the overall sum should be this. Um,
So in worst case, it'll still be
But
10
it's
power
still 10 to the power of 9 only, no? Like,
9 only, right? Yeah.
like
yeah,
how
that,
can it be 10 raised to the power 9? They have actually mentioned that the sum of n will never be 10, greater than that. Like, what are you calculating right now? You are saying, like, what is this 10 raised to the power 9 you are saying? You are just talking about sum of n overall test cases, right? Right?
Hmm.
है ना? But they have actually explicitly mentioned that it will never be greater than 2 into 10 raised to the power 9. Like, I don't even know how to explain this. It is just very straightforwardly written in English.
No, no, that I understood. Uh,
Yeah, so
what is
they
the
have,
meaning of sum of n over all the test cases does not exceed 2 into 10 to the power of 5? Can you explain, like, um, some example?
let's say,
Is it because it's only looping 26 times?
no, it's not about like, it's not about the problem, the solution. It's just that, just imagine if I say that you will have 10 test cases, and the maximum value of n which can be for for a single test case is 100, and I mention that whatever the values of n I take for the test cases, I will make sure that after, like, for all the test cases at the end, the sum of n would never exceed 100. If I say this thing, so now you don't have to worry about the thing, like if I take 100 test cases in all the 100 n in all the test cases. They are just mentioning that this thing can never happen. In, like, they will create the test cases in such a way that the sum of n will never be greater than this. Like in the first test case, they are having n equal to 11. In the second test case, they have n equal to 10. In the third test case, they have n equal to 1, like, and so on. At the end of the day, whatever is the value of n in every test case, if you take the sum of all of this, it will never be greater than 10 2 into 10 raised to the power 5. That is what they have been explicitly mentioning here.
why I was asking this question is I did a very similar thing of what you explained, but and got a TLE. I'm not sure why.
You would have done something else, like I did. The code I have been showing is the code which actually passed all the test cases.
Okay.
At the very least, they have mentioned that for all the test cases, at the end, the sum of n will never be greater than 2 into 10 raised to the power 9. So you don't really have to worry about something like n into t, the total sum of n to be that much. In case if they had not written this line, in case if they had not written this line, then you could have considered that in every test case, the maximum value can be 2 into 10 raised to the power 5. So overall, over all the 10 raised to the power 4 test cases, the maximum, like, sum of n can be 2 into 10 raised to the power 5, 10 raised to the power 9. But they have mentioned that it would never be greater than this. And you will see that generally in almost all the problems, they do mention this thing.
Mhm.
Like,
Okay, so what is the time complexity then? Uh,
yeah, we will come up. Like, you see in the third problem also, even in the fourth problem, they have mentioned it for other things as well.
Mhm.
Even in the fifth problem, they do
yeah,
mention it at the
after
end.
mentioning, like, what is the time complexity now? If we
Yeah,
calculate,
let's look at the time complexity. So for every test case, the time complexity here will be equal to n, like we are having a loop of n here. And for every iteration of n, in the worst case, there will be a loop of 26 inside of it. So for every test case, the time complexity is n into 26, right? And we know that at the end of the day, like when you talk about all the test cases, so the sum of n for all the test cases will be just at max 2 into 10 raised to the power 20, sorry, 2 into 10 raised to the power 5. And every time, like, there will be only that many iterations, this iteration, and for all of those iterations, there will be iteration of 26. So this will be the time complex, like this will be the approximate number of iterations, total iterations.
And here, if you multiply 10 to the power of 4, because 10 to the power
Uh,
of 4 test cases we have, right?
no, that is not the thing. They have mentioned that they will create only those test cases in which, at the end of the day, the sum of test cases, the sum of n over all the test cases, will turn out to be less than equal to this thing. Like in this case, the sum of n is 11, 21, 22, 30, 38, right? The sum of n is 38. This thing, whatever the total all the test cases are, at the end of the day, the sum of all of those n will be kept as like smaller than that. Probably you need to go to the basics once again and look up for the time and space complexity analysis. That's what I would suggest after the PCD. Okay, so any doubts? Anybody having any doubts regarding the problem or something? Shall we move on to the next problem? Okay, great. So this is the C problem. The C problem, choose the different ones. This problem says that given an array A of n integers, an array B of m integers, and an even integer k, we have to determine whether it is possible to choose exactly k by 2 elements from both the arrays in such a way that among the chosen elements, every integer is like every integer from 1 to k is included. And then they have given two examples. So first of all, let's just see what we have to do. We will be given two arrays of size n and size m, and we will be given an integer k as well. What we have to do is, from these n elements we have to choose k by 2 elements, and from these m elements we have to choose k by 2 elements. And for like we want to choose these elements in such a way that all the elements from 1 to k, sorry, all the integers from 1 to k should be included in these total k elements I chose. Like k by 2 plus k by 2 is just k number of elements in total, which I chose from these two arrays. These are like these should be these 1 to k, like all these elements. And then there is an example given to us for more clarity. Um,
Can you repeat that once?
uh, which part?
No, I think you asked some question. I believe. Or
Like
did
you
you
are
ask?
asking about the problem now?
The problem is understood. Okay, sorry. Continue, please.
Okay, okay. So I'm taking one example for more clarity right now. I know that this might be vague right now because we have only talked in words 2385, 2385, 65. This is the first array, and the second array is 13410 5. 13410 5.
What
Right.
could be the rating of this question?
The C problem.
Yeah, yeah.
Um, what should it be? Probably 1200, something like that. I guess
Okay.
12, 1300. Not even 1300, I guess. 11, 1200 should be, I guess. So we have these two arrays, 238565 and 13410 5, and k is equal to 6 here. So what we have to do is, we have to pick up three elements from here, from this array, and three elements from this array, so that all the integers from 1 to 6, that is 1, 2, 3, 4, 5, 6, should be included. Three elements we have to choose from both of these arrays. Right, that's the problem. So let's see if how can we do it. I know that I want to pick up a one, and In both of these arrays, there is only one occurrence of 1. So obviously I will pick up this guy, right? I will pick up this one for sure. So I got 1, and now I have to choose 2 elements from this array. Then like right now we are just logically doing it. Forget about coding, just we are using our common sense. I want to have 2, like I want to choose 2 as well from these elements, and I can see only one occurrence of 2. So I will obviously pick up this one only. So I want to choose two elements from both of these arrays now and cover up all the elements 3, 4, 5, 6. Now I can see 2 occurrences of 3. One of them is here and the second one is here. So right now I don't know which one should I pick up. है ना? Right now I cannot decide which one to pick up, whether I should pick up from this guy or this guy. So let's skip it for now. Let us skip this for now and think about choosing the other elements. So for 4, I can see only one occurrence. So obviously, if I don't choose this 4, I would not be able to pick up all the 6 elements. I have only one choice. I will have to pick up this one. So now I have to pick up one element from the second array and 2 elements from the first array. For 5, again, there are 3 occurrences of 5. Now, it doesn't really matter whether I choose this one or this one, but what matters here is whether I choose the 5 from this array or this array, right? So right now, again, I cannot decide which one should I pick. So I will just pass or skip the move for now. Then for 6, I can see only one occurrence. 6 is coming up only one time. So I will just choose that 6, and 6 has been eliminated. Now I have to choose one element from both of these arrays, and there are 3 and 5 left which are coming up in both the arrays. So obviously it doesn't matter what in what way I pick up. I can just pick up anything like this, maybe 3 and 5 like this, or in the other way. It doesn't really matter, right? So guys, did you understand the dry run, like how we did it and what we had to do? Is the problem clear now? I just did a dry run so that there will be some more clarity in the problem.
Yes, yes, it's clear.
We just have to print yes or no at the end, whether it is possible to pick up all the elements in this way or not. And yeah, at the end it is a 0 0. So maybe we can try to think of it in a way. But yeah, one more thing, k would always be even. K will always be even, or so that k by 2 is always an integer, k by 2 and k by 2. Okay. So see, in the two arrays I have been given, let us look at the most trivial case. The most trivial case right now can be, what if there is some element from 1 to k which is not present in either of the arrays? Let us say there is some element 7 in the range from 1 to k which is not present in any of these arrays. In that case, can I simply say that the answer is definitely no? Because I can never choose 7 from any of these arrays. So at the end of the day, there will be one element from in the range from 1 to k which would not be included. So in that case, I don't really have any confusion. I can straightforwardly say that the answer is no. If there is any element missing from 1 to k, missing in the range from 1 to k in these two arrays, right? Nextly, if there is some element, let us say I talk
Can you
about
just repeat
element. What part should I repeat?
the first point which you made for no?
Like what did you not understand here?
No, no, I did not listen. It got stuck for me.
Like what part were you not able to understand?
No, no,
I
just
just made a very simple claim that if there is some element in this range which is missing in both of these arrays, in that case, I will definitely have an answer. Have the answer as no.
okay, okay, okay.
Okay. Uh, by the way, please be attentive. Like if you just interrupt so many times, then people write on YouTube that please don't attend the doubts while explaining. Trivial means base case. No. Trivial, when I use the word trivial to just talk about the most obvious thing. Here, the most obvious thing was that if I want all the elements from 1 to k to be there. If there is any element missing in both of them, then I can simply say the answer is no. Secondly, if there is an element like 5 coming up in only one of them, let's say 5 is coming up in only one of the arrays. In that case, I have only one choice. है ना? I will have only one choice that, hey, please pick up the element from this array only. You cannot pick up the element from the other array. Right. And if some element is coming up in both of these arrays, in that case, I will have a choice whether to pick up from this or this. Right. So one thing which I can definitely do is iterate from 1 to k and check out if there is any element which is missing. In case if I find out any element which is missing in both of these arrays, then I will simply say no. I will simply print no as the answer. Right. The other thing is, for both of these arrays, let me call the first array as A and the second array as B. I can just keep track of or keep a count of how many elements in the range from 1 to k appeared in both of these arrays. I can do something like this, right? Eventually what will happen is some elements come only in array A, some elements come only in array B, and some elements came in both the arrays. Right. So let us say there were 10 elements in total and 3 came in the first array only. 4 elements came in both of these arrays and the remaining 3 elements came in the remaining 3 elements came in both the arrays. Something like this can happen. है ना? If there was any element which is, sorry, there is one mistake I made. This is not the value of n, this is the value of k, if k is equal to 10. है ना? So k was equal to 10, some elements came in A, some elements came in B, and some elements came in both these arrays. Now, this value would always be less than equal to k by 2, or what did I want to say? Sorry, I think I made one mistake here. Let's just forget about it. Please tell me, is everything clear till this point? The trivial observation we made, and every element would be a part of one of these three things. The other thing which could have happened is there is some element which is not coming in both of these arrays. For that, we have just said we will print now. Okay, great. So let us say there is a case like there are maybe 6 elements which are coming up in only one array, and there is only one element which is coming up in both these arrays, and 3 elements are coming up in array A. And from both of these arrays, I can pick up only k by 2 and k by 2 elements. This is something I know. The problem set you can pick up only k by 2 elements. So if that is the case, then from these 6 elements, I will be able to pick up only 5 of them. I will pick up 5 of them from the array B. Then from the array A, I can pick up the 3 elements which are coming up in only in array A, and there is one element which is coming up in both of them, so I can pick up that one as well. And I will be able to pick up only 4 elements from the array A and 5 elements from array B. So I was able to pick up only 9 elements, right? Which means that I was not able to pick up all the elements from 1 to k. Yeah. So probably you got the idea. You got the idea that if the number of elements which belong to only one of the arrays is greater than k by 2, either for this array or for that other array, in that case, I will never be able to pick up the k by 2 elements from both of these arrays and have all the elements from 1 to k. Just imagine that, let me take up a more generic case, or more like just keeping variables for a little bit of proof, logical proof. I wanted to pick up k by 2 elements and have all the elements from 1 to k being included. Let us say a number of elements, or x a number of elements come only in array A out of these k elements. Xb number of elements come up in only the B array, and xab number of elements come up in both of these arrays. So if the number of elements coming up in like in any of maybe if x of a is greater than k by 2 or x of b is greater than k by 2, in that case I would not be able to pick up the the k by 2 elements which I can pick up from array A. I would not be able to pick up all the elements from there. Let us say k was equal to 10 and xb was equal to 6. So there are 6 elements which in this range are coming up in only array B, but I can pick up only 5 of them. So at least one element would be left which I cannot pick up in the range from 1 to k. So the answer would definitely be no. Does this thing make sense? Does it make sense? That if there is even a single element in the range from 1 to k which I cannot pick up, then I will have an answer no. This is something I already knew. And the next thing which we observed here is, if the number of elements which are coming up in only one of these arrays, let us say xa and xb, if any of them is greater than k by 2, then in that case, since I can pick up only k by 2 number of elements from both of these arrays, so I will have to miss up at least one of the elements which was coming up in only one of these arrays. So I will definitely have the answer as no, right?
Or you can say that if either from either of the two arrays, if any one of them have elements less than k by 2, like for example if xa is less than k by 2, then it's no, or if xb is
No,
less than
no.
k by 2, it's no.
Yeah, the thing which you said is partially correct, but not completely.
No, because it's strictly telling that in
Yeah,
array A
we
or in array
we
B.
calculated this part, है ना? You see, you said that if xa is less than k by 2, then we will also have no. But this thing is incorrect. Let me show you an example here. Let us say xa is 4, xb is 3, and xab is 3. Here,
No,
both
no,
of
no. I'm
these.
not considering both arrays. I'm only considering only A, only B. That's it. Not both arrays.
Okay.
If it is
But for
4,
now,
3,
we have to consider that as well, no? Anyways, the thing which you tried to say was at least partially correct. And if you don't consider this part, then maybe completely. Let's come back to where we were, to the explanation part. We did notice this part, that if any one of them is having more than k by 2 number of elements, then I will not be able to pick up all the elements from the range 1 to k. And I will have the answer as no. Now let's consider the part if xa is less than equal to k by 2 and xb is also less than equal to k by 2. Then in that case, what I can do is, there are xa number of elements which are coming up in only one of these arrays, and it is less than equal to k by 2. So I can just first of all pick up all these elements from array A which are present in only that one. Then from array B, I can just pick up all those elements which are present only in that array. And after that, I will have some elements which I have to I will be having k minus xa minus xb number of elements left, and these are present in both of these arrays. So now I can just pick up these elements from any of these arrays, and I will be able to pick up all of them, है ना? Now I will be able to pick up all the elements in the range 1 to k. So my answer would be yes. So guys, does this thing make sense? Does it make sense how we got to the answer? I tried my best to show you an intuitive way. Um, just in
The
case,
last,
let's yeah.
the last case which you explained, right? This one, xa less than equals to k by 2 and xb less than. Can you just
Yeah.
repeat that part only?
Yeah, I can repeat this. So here, is everything clear till this point? That if any element is missing, then
Yes,
the
yes,
answer will
yeah.
be no.
That,
Or if this is the case,
yes,
then the answer will be no. Now, in the
yeah, those
case
claims
if
make sense.
the number of elements from array A which are coming up in only array A. In the right now we are talking only about the elements from range 1 to k. If the number of elements which are present in only array A is less than equal to k by 2, then I can pick up all those elements, because I can pick up at most k by 2 elements, or actually exactly k by 2 elements. So I
Yeah.
will be able to pick up all of them, and then I will be able to pick up all the elements from the B array as well. So I would have
Yep.
picked up all the elements which are present in either only A or only B. And now I will have only those elements left which are present in both of these arrays. Here I can actually write it as k minus xa minus xb also, है ना? Because I had to pick up a k number of elements picked, and
Okay.
these many are present
Understood.
here, these many are present here. Now all these remaining elements are present in both of these arrays, so it is very easy now. It is now very easy that you, like this case where you had to pick up 3 and 5, and both of these elements were present in both these arrays, so obviously you can just pick up in random order now, it doesn't really matter, right? So
Right.
we will always be able to pick up elements in some way, and the answer will be yes. Now my code for this is like this. First of all, taking up all the inputs. After that, for every test case, I'm having like taking the array, and the array length
This is
is
the previous code.
okay. Sorry, my bad. I just started explaining this part. Okay. Here for the test case of this problem, I will be taking up n m and the two arrays as input. I always prefer to take up the inputs in the array even if I don't have to do anything with it. After that, I you can do it in any way. You just want to find out the number of elements which are present in A and B, and there is a little change in my code. What I did is, instead of finding the elements which are present in only one of these arrays, I found xa plus the number of elements which are present in both these arrays, and xb plus the number of arrays, the number of elements which are present in both these arrays. So uh, or in simple words, I just said key all the elements in the range from 1 to k which are present in this array, just found that count, and similarly for the array b. And I had a little different condition. Though if you understood this way, you can just code it up in this way. Now the part which I'm explaining is optional. You can skip it. In the way I implemented, I said key find out the number of elements which are coming up in array A. Either it comes in B or not, I don't really care about it. So it would be equal to this many elements. Basically, all the elements from 1 to k which are not coming up in only array B, either they are coming up in array A only or in both these arrays. And similarly for array B, and both of these things should be greater than or equal to k by 2 now. You can just get these conditions from this part very easily. If you don't understand this part, there is no problem. You can code this thing. It will also give the correct output. So that's what I did here. First, I just stored the elements in a set so that I will be able to find out if the elements are present or not. Created a boolean not found with name not found to keep track of the just to keep track if there is any element which is not present in both these arrays, and kept a variable count a and count b, which will tell me how many elements from 1 to k are present in the array a and the number of elements which are present in array b. Then I'm having an if condition that if some value I which is not coming up in array a and array b, in that case just set the value of not true to true, sorry, not found to true, and break out. So it will tell me that there is some element which is not coming up in either of the either of the arrays. And here this dot count function actually returns me either 0 or 1 because I'm having a set. So the count would be either 0 or 1. I'm just adding it up. So it will just increase by 1 in case if I is present in the array A. Otherwise, it will not increase. And similarly for array B. So eventually what will happen is at the end of the loop, I will have count A will tell me the number of elements or the number of integers from 1 to k which are present in the array A. And similarly for array B. So now I'm just checking if there is any element which I could not find in both of these arrays, then print no. If the minimum of count A comma count B is less than k by 2, it means that it means that uh like see, count A is nothing but this thing, k minus the number of elements which are only present in array B. And if this thing is, if for any count A or count B, if it turns out to be less than k by 2, if count A turns out to be less than k by 2, it means that k by xb would have been less than k by 2, which would have mean that xb was equal greater than k by 2, like this condition. So the conditions I wrote here is nothing but this exact same thing. I just got this thing during my mind during the contest, but I felt this to be more intuitive for explaining. So that is why I explained it in this way. So this is the condition here. And in the other case, when both of them are having at least k by 2, then the answer would be yes, like the case we saw at the end. The else case is talking about this condition. Okay, so is it clear, like whether the logic is clear or not? For the implementation, there is no problem in case if you feel this as a bit confusing. I would recommend you to first of all code it in the way we discussed during the logical part, the logic building part. After that, once you have implemented it in that way, try to figure out this way of implementation as well, because it will um, get you more comfortable with implementation. Practice is important. Great. Let's see the D problem now. Find the different ones. In this problem, we have been given an array of n integers and q queries. Each query is represented by two integers L and R, and our task is to find out for each query the two indices I and j, or determine they does not exist. And then there is the condition on, like the condition on what basis we have to decide I and j. Both I and j should be in the range from L to R, and the values on those indices should be different. In other words, in simple words, for each query, we have to find a pair of different elements among the elements from AL to AR, or report that such a pair does not exist. I hope that the problem should be clear with the problem statement itself. It is quite straightforward that we have been given an array for, and we will be given some queries. For each and every query, we will be given some starting index and some ending index. We will have to tell in the range from the starting to ending index whether there exist, or we will have to actually tell two elements, give the indices of two elements which lie in the range which we have been given in the query, and the values on those indices, let's say a and ai and aj, should be different. These two should not be equal. So is the problem clear? In case if no such two elements exist, in that case we have to print I equal to j equal to -1. Otherwise we have to print I comma j as the answer of the query. So is the problem clear? Okay guys, वैसे respond नहीं कर रहे. There are 14 people in
Basically,
meet and nobody is writing in chat.
basically हमको we should insert all the elements from L to R, like the from query, into a set, and then size of the set should be greater than 1, correct, for every query.
Yeah, you can do that thing. You can do that thing, but you have to find out the indices of two elements as well.
Yeah, set
And
of pairs we can do. The number and its index we can insert as pair in the set.
no, in that case it won't work. In that case, even if you have the element 4 coming up at two different indices, let's say 10 and 12, then if you store 4 comma 12 and 4 comma 10 in the array, in the set, it would have these two as two different indices, two different elements.
Okay, okay.
Yeah. And one more thing, it would not be efficient either. We have to get some efficient solution. Let us look at the time constraints. So for every query, sorry, the size of the array is 2 into 10 raised to the power 5. The size of the array is less than equal to 2 into 10 raised to the power 5. And the number of queries is also less than equal to 2 into 10 raised to the power 5. So probably we should think about something like big O of n log n or n log, sorry, um, q log n, something like this. That maybe we can do some pre-computation if required, and after that, like pre-computation with less than equal to this time complexity or a little bit greater than this. And for every query, we should try to find our solution in either log n or log square n, or in the worst case square root n, something like this for every query. Okay, so let us see what can we do. Would you guys like to have a guess on at what time will we have the answer equal to -1 and -1? Let me draw it like this. The array is, let's say, looking like this one, and I gave the two indices as this index, like this index and this index. So in what case will you not be able to find out two different elements in this range? Try to think about it.
If all are same in the range.
Absolutely correct. If all the elements in the range are equal, in that case, I will not be able to give two different indices I and j. है ना?
2 pointers
If
लगा
there,
सकते हैं.
what?
2 pointers लगा सकते हैं ना फिर.
No, two pointers will also not work here. Like, what will you do with two pointers? If you see everything is random here, so two pointers will not really help. But one thing is, just see from the first element, if there are at least two different, let us assume that if there are at least two different, like two different elements in the array, then this first element of the range will definitely have one element different from it in this range. Will this always be true? Try to think about it. Will this always be true ki from the first element of the range, one of the elements in the remaining range would be different from it if there are at least two different elements in the array?
So we can place first pointer at the first element and second pointer at the last element, and we can move first to the left side and the other one to the right side, like that, one by one.
No, it will not work. And please try to think on what basis do you think it should work? Like, try to think about it. You
If
will realize that
first and the last element is equal, we will do I plus plus and j minus minus, like that. If any
uh,
one time both I, like I and j index element
logic
are
is
different.
not working. What if there are four elements in the array? The first element is 10, last element is 10, the second is 2, last second is 2. You said you will compare these two. These two are equal, so now you will compare these two. Again, these two are equal, whereas if you had just compared all the elements from the first element itself, you could have got it very easily. You know? So I hope you got the mistake here. Did you get this? Did you get the bug here? Hello? Did you get this bug here?
Yeah, but for like this, we'll need two loops, right?
Um, no, for the first element,
One loop to fix I pointer and the second loop to move j pointer from I plus 1 to the end of the query range.
that is what I was discussing just here. That if you see, if there are at least two different elements in the array, then there
Then we
will
can break
at
away.
least one element different from the first element in the array. try to think of any case where all the elements, like there is no element different from the first element in the whole range, and there are at least two different elements. Is it anytime possible? Like my claim here is, if there are at least two different elements in the array, in that case, from the perspective of the first element, there will be at least one different element in this range. There will be at least one element in this range which is not equal to the first element. This
Correct.
thing, है ना?
Correct. Absolutely.
Because if you just if you are not really sure about it, you just assume that all these elements are equal to the first element, so that there will be no element different from the first. Then in that case, you will see that you just got this thing contradicted. In that case, all these elements are same, so there will be, like, there will not be two different elements. So you will see a contradiction, which proves that there will be at least one element different from it in this range. So if for every element I just store the index of the closest element on the right, which is different from this element, in that case, I can just check that, hey, which is the closest element to you on the right side for this guy, which is different from you. Let us say that closest element is here. In that case, now I can just compare this closest element, that whether this is inside the range or not. If it is inside the range, then I just found that these two elements, like this I, and let us say that there is something like next of I, which will tell me the closest element on the right side of index I, which is not equal to I, which is not equal to A of I. Sorry, it will tell me the index, the uh, index of the closest element. है ना? You want to store the index of the closest element here. Whose element, such that, just I'm just defining it here so that if anybody has any confusion, it might just get out here, where AI is not equal to A of next of I. Okay, so I just wrote some formal way of saying about next. Feel free to ignore this. The main thing which I want to say is, if for every index I know the closest element on the right, which is not equal to this element, in that case I can just check that if there is a 7 and I know the closest element on the right side which is not equal to 7, let us say there is a 10 here, it would store here, here is the element which is not equal to this, then I can just compare that whether this element is inside the range for the query or outside the range. If it is outside the range, then the answer will be no, otherwise the answer will be, sorry, if it is outside the range, then the answer will be -1 and -1, otherwise the answer will be the same.
No, to avoid going outside the range, you can iterate over I to j only. No.
If you just iterate over this whole thing, in
Yeah.
that case you will have a time complexity of at most big of n, because in the worst case, the left thing could have been here and the right thing could have been here, so you might just iterate over the whole array for every query, and if you just have a big of n time complexity for every query, your time complexity will go big of n into q, which will not work. N in q can be very huge, 2 into 10 is the power 5 and 2 into 10 is the power 5, है ना? So the thing which you are saying will definitely give you the correct output here, but it is not efficient enough to pass the solution, pass the test cases. And that's why we were discussing that for every query you would like to have the answer in big O of log n. Okay, so somebody said that use segment trees. Actually, no. Segment trees will just become complicated and it's just overkill, even if you can do it with segment trees. The thing is, you just want to store the index of the next element, which is not equal to 7. So just compare up to like, just say that in this array you are comparing these two elements. Let us say if this is index I and this is index I plus 1, if ai is not equal to a of I plus 1, then would anyone like to tell what will be the next of I here? What would be next of I here? Would anyone like to tell what will be the first index on the right side of this I, which is not, which is having its element not equal to ai?
I plus 1.
Absolutely correct. If the next element is not equal to the current element, then you will have the, you can just store that the next element is the element, the first unequal element you will find. But what if ai and ai plus 1 were equal? In that case, what is the first element on the right side for this I, which is not equal to ai? How will you find this thing?
Keep moving right of I plus 1.
Yeah, one thing you can do is just keep moving on the right side, or just you can say, yeah, if you know about like whatever answer you get for this next of I which you get here, the same next of I plus 1 would be, है ना? Because both of
Yes.
these elements are same. So on the right side for both of these, you will have the same answer. So what you can do is just start iterating from right to left and keep track of the next of I. If you find out two different elements, then you can just set next of I equal to I plus 1. If you find out two equal elements, then say a next of I is equal to next of I plus 1. In this, you would have already got this thing because you are iterating from right to left. And in this way, you can just find out next of I for all the elements of the array, right? Yes or no? Yep, Udit said the same thing. Udit said the correct thing here. Okay, so if this thing is understood, now the remaining part is very simple. It's very, very simple now. Let us say this is the range. I just simply know that, hey, for this element, I can just find out the first element which is not equal to this. If this is the index I and I get, or maybe let me call this as L. Let me say that I have been given two indices L and R. So I can just check out for the first index in this range, which is just L. If next of L is greater than R, it means that the first element which is not equal to this guy is outside the range, will be actually outside the range. It would be anywhere up at this place, which means that all of these must be equal, which means my answer will turn out to be I equal to -1 and j equal to -1. Does this part make sense? In case if next of L is greater than R, then my answer would be this. And if next of L is less than equal to R, then it is even simpler. In that case, I can just say I is equal to L. I just fix my first element at this place. And for the second element, I just have it here. Like J would be equal to next of L. Next of L is something I already know that it is different from L, like A of L. Hana. Here, I already know that A of L would not be equal to A of next of L. Only on that basis, I did create this next of L array. So this is how I can just get the two different elements if they exist. And if this condition comes, then I already know that this does not exist, right? Can we move on to the code? Guys, please write yes or no. There are 13 people in Meet and only 2 people or 3 people are writing in chat.
Explain time complexity, no? Then what your
Okay.
approach?
Yeah, we can, or maybe we can discuss the time complexity after discussing the code, because it would be more easy for everyone to understand it there while looking at code. Okay, so let's see the code and we will discuss the time complexity here. It would be easier here. First of all, for every test case, I am going on and taking the inputs. Here I am taking the inputs for the array. I have not taken the queries, like I've just taken up the number of size of the array and the elements of the array. After that, I'm calculating this next array where I initialized the element with n, like you can initialize it with anything greater than or equal to n. Or if you initialize it with -1, then you will have to write some if else conditions also. And here I'm running up a for loop from right to left, where for every element I'm having two conditions, which we discussed in the logic part. If the elements are equal, in that case, next of I is equal to next of I plus 1. Otherwise, next of I is equal to I plus 1. Then I'm taking the queries, and for every query, I'm having L and R, the left and the right part. Since I'm having everything here in one zero-based indexing, I'm converting L and R to zero-based indexing by subtracting minus like 1 here. That is L minus minus and R minus minus. And then I'm saying ki in case if the next of L is greater than R, it means that all the elements in the range must be equal. And otherwise, I will just answer L plus 1 and next of L plus 1. I'm adding plus 1 here to convert 0-based to 1-based indexing. So I hope that the implementation is clear. Like this one was pretty straightforward. Now let's look at the time complexity. For every test case, this is like the part of declaring a vector and taking inputs will take big O of n time complexity. Then finding this next array is also taking big O of n time complexity, because in every iteration of the for loop, I'm just having big O of 1 operations. After that, for every query, I'm just answering it in big O of 1, not even log n. I'm just answering it up forwardedly in big O of 1. Now, so for every test case, the overall time complexity I get is equal to big O of n plus big O of q. Like all these things I did earlier were taken just big O of n, and after that I'm having a loop of the q. So I'm having big O of n plus q as the time complexity for every test case. Now, since this is happening for every test case, and eventually I will have a lot of test cases. So if I talk about the like all of the test cases, it will turn out to be big O of sum of m plus sum of q over all the test cases. And we have been given sum of n to be less than equal to 2 into 10 raised to the power 5, and similarly for q. So this thing would be less than equal to 2 into 10 raised to the power q, sorry, 2 into 10 raised to the power 5, and this thing would also be less than equal to 2 into 10 raised to the power 5. So the solution is having less than equal to 4e, like actually less than equal to 1e6 iterations, or even less than that, not being equal, right? Is it like correct? And if we have the number of iterations going on till something like 1e8 to 1e9, it is being considered at least below 1e8, it is being considered safe. From 1e8 to 1e9, it is kind of 50-50. Okay, so let us see the next problem. This is
Can
the
you show the
problem.
code 1 minute? The previous one.
Yeah, you can see this.
Yeah, here this loop. Can you explain for I equal to n minus 2? This thing.
This one, okay. So what we are doing here is, as we know that for finding out the next of I, sorry, let me make it full screen. Yeah. So for finding out the next of I was willing to have next of I plus 1 to be known already. Hai. These two things were gonna be same. So I just wanted to know kya next of I plus 1 kya hai. And for that, I knew ki since I want to find this thing first, it would be great if I am having a loop running up from right to left. Right now, I'm not really willing to go in a lot of depth because this is some sort of simple dynamic programming here. So that's why I'm explaining in a basic way. If these elements are same, in that case, I will just say that the answer of this current index would be equal to the answer of the next index. because these two will have the same element on the right side, which is different from both of them. And in case if the next element is different, then the answer would be just I plus 1. So were you willing to ask the same thing or something different?
The else part I'm not understanding.
Okay, so if I say it as AI is not equal to AI plus 1, next of I equal to I plus 1, is it fine now? Do you understand this part? If the next element is not equal, then next of I is equal to I plus 1. I think that you were the one who actually answered this when I was asking. When I asked question, somebody even gave this answer, right? That if two elements are not equal, if this element is not equal to this one, then the next element for this guy, the first element
Okay,
on
okay,
the
got
right
it.
side.
Yeah.
Yeah. So that is the thing. Now I have just written up else here, which is gonna be the same thing, that the element is not different. Sorry, not same. Okay, so let us see the next problem then. The problem E. The problem E says that we have been given two integers n and k, where k is even. Wait, we did solve a problem. Was it different? Okay, so this one was also having even. Okay, no problem. Let's come back. You are being given two integers n and k, where k is even. A permutation of length n is an array consisting of, they have just given up some explanation over what is a permutation of n. I think we already know that a permutation of n is nothing but uh, a set of a sequence of n elements where all of the elements from 1 to n are coming exactly once. And our task is to construct a k level permutation of length n. Then they have told us a permutation is being considered to be k level if among all the sums of contiguous segments of length k, there are this many segments, the two sums differ by no more than one. I know that this is a pretty vague thing. No problem if it doesn't look good. They have explained it more formally. To determine if the permutation P is k level or not, first construct an array S of length n minus k plus s, where Si contains the sum of the elements from I to I plus k minus 1, and the ith element, s of I is equal to the sum of the elements from Pi to P of I plus k minus 1. Then the permutation is k level if the maximum of S minus the minimum of S is less than equal to 1. And we have to find out any k level permutation of length n. We will be given n and k, and we will have to print a permutation of length n such that it is a k level permutation. So let me draw this here. Now, since this is the div2e problem, we will go up a little faster. Like, we will not discuss complete basics.
What is the rating of this question?
I think it should be somewhat like 14, 1500. In the problem, we have been given an integer. Okay, before that, let's see the problem. A permutation of n, let me call a permutation of pn. Let me denote it by pn. Sorry, let's say we have a permutation of length n. It would be nothing but all the elements from 1 to n coming up exactly once in the array, and they can come in any order. So something like 2, 1, 5, 3, 4 will also be a permutation of length 5, right? This is a permutation of length 5. And we say a permutation to be k level if if you just find out the sum of all the subsegments of length k. First of all, do this thing. So let me say here n is equal to 5 and k is equal to 2. Then this is a subarray of length k. This one is a subarray of length k. This one is a subarray of length k. Let me just This one is a subarray of length k, and this one is a subarray of length k. It has a sum of 3. 2 plus 1 is 3. This has a sum of 6. 1 plus 5 is 6. 5 plus 3 is 8. And 3 plus 4 is 7. Right. Just find out the sum of all these subsegments and then check if the maximum one of them minus the minimum one of them is less than equal to 1 or not. So here the maximum mx is equal to 8 and the minimum is, here the minimum one of them is equal to 3. Here mx minus mn is actually turning out to be 5. If it comes out to be either 1 or 0, in that case it is a k level permutation, else it is not. So does the problem make some sense here? We will be given some n and k and we will have to print any permutation which satisfies this condition. So guys, yes or no, whether the problem is clear or not?
The max minus min should be less than or equal to k, you're telling.
No, it should be less than or equal to 1. Mx minus mn should be less than equal to 1. Let me show an example as well of a permutation. Let's see, they would have given something. Yeah, they have given, let's see this permutation. 1735, 1735, 264, 2, 6, and 4. Let me erase this here so that we will have some more space. And here n is equal to 7 and k is equal to 4. So for like length 4, how many subarrays are there? This is the first subarray from 1 to 5. It is having a sum of 8 plus 8, 16. Then we have this subarray of length 4. It is having a sum of 70. Then we have this subarray. This subarray is having a sum of 7, 9, 16. And then we have this subarray having a sum of 17. Right. The maximum here is actually coming out to be 17. And the minimum is coming out to be 16. Mx minus mn here is less than equal to 1. This condition has been satisfied. So this is a k level permutation. K level what? Yeah, k level permutation. So like now do you understand how would a k level permutation look like?
Can the difference be like -2, -3 also?
Minus k? No, the difference should be less than or equal to 1 only. Even if the distance is difference of max minus min is equal to 2, it would not be a k level permutation.
Okay, okay.
No. Okay, so great. Now I will go on with the way I approach this problem. So the first observation I had in my mind here is, just look at the first two subarrays of length k. The first subarray of length k will have elements a0, a1, a2, and a3. Right now I'm taking k equal to 3 for explanation purpose. And in the second subarray of length k, I will have elements a1 plus a2 plus a3 plus a4. Right. And now you can already see that three of the elements are equal. Only these two elements are different. And since I want like whatever comes up to be the sum of these, let me call this as S0, and the sum of these four elements, which turns out to be, let's say, S of 1. I want that absolute difference of S of 0 minus S of 1 should be less than or equal to 1. Right. I want this thing to happen. So this like in S0 minus S of 1, you can see three elements are common. So when you try to simplify it, you will realize that absolute of A0 minus A4 should turn out to be less than or equal to 1. This condition will come up. Now, since you want the absolute of a0 minus a4 to be less than or equal to 1, it means that a4 must be either a0 minus 1 or a0 plus 1. A4 has only these two choices. It cannot be anything else. Similarly, if you talk about the third one, the third subarray of length k, it would have elements a2, a3, a4, and a5. So again, you see that you have two conditions now. Like the first condition is that absolute of s of 0 minus s of 2 should be less than equal to 1, and absolute of s of 1 minus s of 2 should also be less than equal to 1. Hana, you know this thing. And there is one more thing. The absolute difference of a4 minus a0 minus a4 cannot be equal to 0, because in the permutation all the elements are unique. No two elements can be equal to each other. So we already know that a0 and a4 would be different. That is why I have said ki a4 would be either 1 less or 1 greater. It cannot be equal to a0. We already know about that. So absolute of s0 minus s1 would have been either 1 or 0. Now, for now, let us consider that if you had taken a4 to be, if you were considering a permutation in which a4 was greater than a1, like a0 plus 1, a4 was equal to that. So here, like when you will solve out this thing, you will realize that like you will get a very similar equation, that absolute of, on solving s1 minus s2, you will see that three elements are equal. A1 and a5 are different. These are the only two different. So absolute difference of a1 and a5 should also be equal to less than equal to 1. Since these cannot be equal, you will see ki a5 must be equal to either a1 minus 1 or a1 plus 1. And now you can notice that if I had taken a4 as greater, like a0 plus 1, then a5 must have been a1 minus 1. In case if I take a5 to be a1 plus 1, then the absolute difference of s0 minus s2 will turn out to be 2. Because you already know that if you are comparing these two subarrays, these elements are equal, and this a4 is already 1 greater than a0. So this a5 must be 1 less than a1, only then the sum, absolute sum, can be less than equal to um, can be less than equal to 1. Let me check out the battery once, because if it goes out, I will be messed up. Okay, it is 6%. I hope it runs a little more. Okay, coming back to where we were. Like the problem is almost done. Just don't worry about that battery. We know that for a5, in case if you had taken a4 to be 1 greater than a0, then a5 must be equal to a1 minus 1. And when you try to do the same, like similar thing for the next subarray, you will get a relation that a6 now must be equal to a2 plus 1. Like whatever you did in the last part, every time it is just getting reversed. You did plus 1, now minus 1, then plus 1, then you will have a7 equal to a3 minus 1, and so on. So
I'm
I
not
did notice.
understanding. I'm not understanding what is the connection. Like, if A4 is 1 greater than A0, then what is the guarantee that A5 should be 1 less than A1?
You can just compare these two subarrays. You know that the difference, absolute difference between them must be less than equal to 1. है ना? You already know that you are talking about the case when a4, you have taken a4 as 1 greater than a0. So if a5 is also 1 greater than a1, in that case this will have a sum greater than this, 2 greater than this at least, which is something we cannot have. So this a5 must be equal to a1 minus 1 only. In case if you are not able to get this part right now, after the session I would like like I would suggest you to write this thing on pen and paper. Um, right now, because of low battery, I can't really dry run the whole process, and it is very simple. You will just get it very easily once you try to write for some permutation. You will see that a5 must be equal to a1 minus 1 only if this a4 was greater. And similarly, a6 must be greater afterwards, because if it is also less, then you will see the similar kind of problem in S1 and S4 and so on. Like you will get this kind of a pattern. So what I did is I just thought ki in the array I have, I just did notice this part key, whatever value I place at a0, let me place 1 there. Then at the index a of k, I will have to place an element 1 greater than this, like a4 was 1 greater. And I did notice one more thing. A8 came out to be a4 plus 1. So at the index 4 indices later, there should be 2, which would be 1 greater than the a0. And similarly, at a8, I know that it would be 1 greater than a4, so it would be 3 here, and so on. I did notice this part, and then I just got this kind of a pattern in my mind. I did cross verify that whether it is correct or not, and it turned out to be correct. So that is what I did right now. Just because the battery is very low, I can't really show the complete pattern, and believe me, this is something very simple which I'm leaving right now. Let me show you the code, and then probably my laptop will just get off by then. I can't charge the laptop right now, probably. Okay, so the code is very simple. I'm just printing up this pattern, having low and high right now, and having these kind of two for loops, which will overall have a time complexity of big O of n only, because this loop is going on from I to k, and the other loop is having a time complexity of n by k. So overall, these two for loops will have a time complexity of big O of n. I'm just printing up elements in this way, that one is being printed at the first place. Then I'm printing 2 after k indices. Then I'm printing 3 after k indices, which I noticed from here. A of k was equal to a of 0 plus 1. A of 2k was equal to a of k plus 1. Similarly, if n is very huge, you will see ki a of 3k, which is a of 12, will also be equal to a of 8 plus 1. If you try to redraw this pattern more longer, you will come out to this part as well, and so on. So I just did put up something like this. Just run up a for loop from uh, for I equal to 1, and go on to all the indices till where you can. Then for starting on from second index, going on kk indices on the right, and reducing the values by 1, and so on. Now this is, like, I think, pretty simple. It was kind of a constructive algorithm problem. So just getting the pattern in the mind was the hard part. After that, I'm just printing it out. So that's what I did. So for now, I hope that you like the session. Bye, guys.